on this computer. Okay, so you click on the folder and you have all these files there. You just click on this data se.exec executive file. Can you see my screen? Hello?
Yes, Professor, we
Okay.
can see.
So click on this stata se.exe, this exe file. This is the file basically you will be using. When you click on that, you will end up with this screen. Obviously, this side here is any file from Microsoft is this. So it looks like exactly like that. So no worries about that. And you have this command here. Here is where you write your comment. There is one more way. We'll show you that later on. So this is the command file. And
Professor can't see.
you cannot see?
No.
Huh?
No, I can see only the file in your folder.
Only the file, you can't see the screen?
Yeah, but whatever you are saying right now, I can see the command, the variables thing.
Others?
Professor, we can see the folder you open and
Okay.
yeah, so like you did not click, I guess.
Okay, I have to click again then. I'll click again. Share. Here. Now can you see?
Yes.
So you click on the executive file, exe file, and then once you look at this icon in the executive file, you have this icon here. So you click on that and you end up with this screen where, see, in the menu bar, this is like any other Microsoft based software, file, edit, but there are some new features here: data, graphics, statistics. I will not use everything, yeah, but I'll give you the basics of data. And anybody wants to really learn, uh, you know, to be skilled on a software, you have to play with the software. So here for us, we will do the basics, and I hope you will be able to use it from then on. So first thing, here is a command box here. You can write your command for the software, or there is another way, which is here, new do file editor. So two ways to write the commands. We'll write it here, and here is the log and result. The result will be here. Outputs will be in this box here. And this is the log here. So no worries, let's do work with some data. Now, data can be built in with the software. If data is built in with the software, then you can use the data. Or you can import data from other software like Excel. So let's use a data file from this software, built in this software. So if you want to use a data file which is there in the software already in there, you use one command like here, first word. Can you see the word first word? Huh? Hello?
Yes, Professor.
What is this?
Yes, Professor.
What is this? First word. Can anyone read that?
Professor, sysuse LifeX.
Okay, LifeX is the first word is sysuse. SYSUSE. It's telling you, so this is a command word, sysuse. System, sys is for system, use means you use from the system. So this is a command word, sysuse. And the second word Life exp is the name of a file built in with the software. Okay, so we are going to use the file life expectancy. Basically, life expectancy, the title of the file is LIFEEXP. If you change this, they will not find the file. You have to write exactly this file, this name, and the command word you cannot change. Sys use. So we are going to use that file live exp, and the command is, I'll share with the commands with you guys. So and then you put enter. Okay, here see sys use live exp. The file is actually life expectancy file from 1998. What are the variables here? To the left, here are the variables in that file. Everything is now ready to use. Region, name, level, type, format. Region, one variable is region, label is region. Another variable is country, label is country. Third one, population growth, pop growth. Pop growth means population growth. So these are all the variables there. Pop growth, average annual percentage growth of population, LEXP. What is LEXP? LEXP is life expectancy at birth. GNP-PC, what is that? GNP per capita, a safe water, which is not labeled, and it's safe water. So these are the variables in that file. What is the title of the file? Life exp, without any space in between. LIFEEXP. LifeX is in the file. In the software, we have kind of called that file from that software. And when you write this, everything is in. What are there in the file? All these variables. If you want to see the variables, let's say we want to see some of the variables. This is one command, list. When you say list, then you have to give the title of the variables. The variables, let's find let's say the variable like country and pop growth, or you can put it from here, LXP. So you click here, they will be ready here. So we would like to see the values of these variables. What is the command? List. When you say list, or you can say browse also, either way. So it's a list, then these four variables, country, pop growth, LXP, GNPPC. What is GNPPC? GNP per capita. So this is a file of life expectancy, and when I wrote this, all the variables are ready to be used, and I would like to see some of them. The variables, I said list, and the variables, space variable name, space variable name, space variable name, and then say hit the enter, and once you hit enter, the variables are here: list, country, pop growth, LEXP, GNPPC. See all the variables here: country, Albania, Armenia, Belgium, Bosnia-Herzegovina, Denmark, Germany, Greece. Pop growth, 1.2%, 1.1, 0.4, so on. LEXP, life expectancy at birth. Let's say Albania, 72, Belgium, 78, and so on. GNP per capita, and so on. Okay. So you say life system use, life expectancy. The file is ready to be used. then first thing we do is we try to see what the variables are like, the values and all these.
Professor,
Yes.
so to open any kind of folder, we need to always write sys use in the command and then the folder's name, right?
SYS use means there are some files already in the software
Yeah.
data. Okay.
Yeah.
So sys use is a command to call that file from that software.
Exactly.
Okay. If you have your own file, let's say in Excel, there is another way to use Excel file. We'll show that also. Most likely you have your own file. You are doing some research. You have your own file in Excel. You can bring it here, import it here and use it.
Professor, that time do we write sys use?
No.
System use?
No. That's another way. I'll show it later on, okay?
Okay.
Professor,
Yeah.
Professor,
Yeah.
when I give the command sysuse life expense, it written that unrecognized command.
No, then you wrote something wrong. This is a very widely used command. SYSUSE space LI. This is the file name. So LIFEEXP. You should be able to. If you cannot, then there's something some other things is wrong, not this command. Okay. If you write something else instead of sysuse, then it will not work. So then what else do you want to do? Let's say you want to do some descriptive statistics, mean, median kind of. Mean of the variable, median or upper value, standard deviation. In that case, you can write sum or summary. Sum for summary. You don't have to memorize. I'll share the commands with you. So when you say sum, it means they will give you the descriptive statistics. So let's say these three variables, you have values. So I'll say pop growth, life expectancy, GNP per capita. I would like to see some descriptive statistics like mean, standard deviation, max values, mean values. If you write sum, then right away they give you the table for these three variables here: population growth, life expectancy, GNP per capita. So what you do, you write sum or summary. You can write full summary also. The variable names here, and then obviously space in between always, and then hit enter. Then everything is here. How many observations here? Population growth, 68 observations. Life expectancy, 68 observations. GNP per capita, 63 observations. 5 missing values. 5 values are missing. Mean. What is the mean of population growth? It's just a sample mean. X bar. Population growth for the mean of all 68 countries. Mean population growth is 0.972. Life expectancy for all 68 countries, life expectancy at birth is 72.27 years. GNP per capita for 63 countries, mean is average, obviously, X bar kind of, $88,674. Okay, so here is mean values. Standard deviation of this, say population growth. Mean is 0.97, standard deviation is 0.93. Minimum value Minimum population growth is minus 0.5. Maximum population growth is 3%. Life expectancy minimum is 54, maximum is 79. GNP per capita minimum 370, maximum 39,000, almost 40,000. So that's how you get the descriptive statistics. Any research you do, first thing you do is some descriptive statistics like mean, standard deviation, minimum values, maximum values, and all this. So is that okay? So far?
Yes.
All right. Then what else? Then you can do some scatter diagram. Remember scatter diagram we asked, plot the variables, scatter diagram. Let's do a scatter diagram between GNP per capita and life expectancy. GNP per capita and life expectancy. We would like to see actually whether there is some relationship, visual inspection, just to look at the scatter points to see a relationship between GNP per capita and life expectancy. So let's do GNP per capita later on here. So what is the command? The command is simple. It's a two-way. So two-way means horizontal and vertical axis. And within parentheses, what do you write? Scatter. Remember this, scatter. Two-way, within parentheses, scatter, space, one variable, space, another variable. And then if you hit the enter, you will see the scatter there, all the points.
Professor, why did you write two-way?
That is the command. That is the command word. I can do nothing about the command word, okay? I can do nothing about these words are already defined for the software. When the software says two-way, then it knows that it's going to do a scatter in the horizontal and the vertical. First one should be on the vertical, life expectancy on the vertical, GNP per capita here. So this is why this is XA. So life expectancy on the vertical, here on the horizontal. I cannot answer the question why commands are like that. Commands are like that, we have to use those commands. These are software engineers put these commands there. For us to use them. So all these points, how many points are there? Huh? Hello?
So many.
Several points.
So many. How many? How many observations do you have? Here. Life expectancy 68, GNP per capita 63. So here you will have 63 points here. One GNP per capita corresponding one life expectancy. So what do you see? Relationship? What do you think?
So Professor, if we want to find out only life expectancy, then we have to write one way.
No. What do you mean by only life expectancy? Can you draw?
There are two things, right? Life
Has to
expectancy
be,
and
has to be two
GNP.
things. Scatter diagram. This is scatter diagram. Don't you need two variables to draw a point here?
Yes.
With one variable, can you draw?
No.
Yeah, that's why. So two variables here.
Okay.
Professor, so first do we write the vertical axis and then we write the horizontal axis?
You will try it, you always do trial and error. Here you can see that if you write y first and then x. Okay, so vertical x, whatever you want to put vertical on the vertical axis, you put it first, then horizontal axis later on. Okay, yeah, this is the way you have to write. If you write the GNP first and this later, then obviously they will flip. They will put life expectancy here and GNP per capita on the vertical. Let's try that. We can try that also. I mean, no harm. It's a trial and error. You will see that it will be the other way. Here, let's say two-way GNP per capita first and then life expectancy. This is just our learning process. So here, GNP per capita first, life expectancy later, and then you will see the look here now. Oops. Can you see the scatter diagram here?
Yes.
Yeah. So you see now life expectancy at birth here, GNP per capita on the vertical. So, you know, if you want to draw a scatter diagram, because when you do research, this is a very good thing. When you do, first thing you do is a descriptive statistics. Explain that. So you have some sense of the variables. Then you have some focus interest. Let's say if your interest is what happens to life expectancy at birth when GNP per capita increases, what is the relationship? Then you can do a scatter diagram to give a first look, cursor look at the relationship. You can see that there is a positive relationship. It looks like there is a positive direct relationship. One increases, another also increases kind of relationship is there. When you do research, these are the good ideas to do. All right, so two things we did, three things basically. One, we have listed the variables, so we know what are the values in the variables. And then we did descriptive statistics, then we did a scatter diagram. What else we can do? Okay, if you need a new variable from the old variable, you can also generate new variables. Meaning what? Suppose you have a GNP per capita. You want you want to generate a log of that. How do you do that? We will generate a couple of new variables from the old variables. Let's say you want to find a log of GNP per capita. What is the command? Command is GEN. From generate. You can write GEN. So we'll do a few new variables just to show you how to generate new variables from the old ones. So what old variable we have? We already have a GNP PC. Now we want to find a log of GNP PC. So I called it log GNP PC without any space. I wrote log GNP PC. You can call it anything, okay? I called it log GNP PC so that you know that this is a natural log of GNP PC. How do you do that? Here is the command. Here's how you do it. ln. So basically doing natural log, ln within parentheses this variable GNP PC. So gen, then you give a title of the new variable, whatever title you want to give, and then equals, if it's a log, then you write ln within parentheses the variable that you already have, and you are converting that variable into a log variable. So gen, then you enter. Then log is already generated, but 5 missing values, you know, sometimes log is not defined over maybe negative values, or oh no, five values were missing here. You see, GNP per capita, you had only 63. So 5 were already missing, so they could not generate log of those 5 missing values. But you want to see, you can see again, you can say list. So we will put list. You want to see any variable, you can put it there. So I'll put log GNP per capita, also log here. You see, it's already generated here. I'll put it here. So these two variables will be shown. You can see side by side. GNP per capita, log of GNP per capita. If you write list, they will show you here. See, I put it both because so you can see that actually log variables are generated. 810 natural log is 6.697. 460 natural log is 6.131. 26830 natural log is 10, and so on. So logarithms are generated. GNP per capita and log variables are generated. You want to generate a square. How do you generate a square? Let's say you want to generate a square of GNP per capita, any variable which is so how do you generate a square? What do you want to call it?
SQRT.
SQRT, SQRT, GNPPC, okay? Because this is the square of GNPPC, not any other variables. So let's call it SQRT GNPPC. How do you generate it?
Again, SQRT in bracket GNPPC.
Maybe I would do this. This is one way. GNPPC times GNPPC. Okay, that is possible. That is one. Let's see. So that is one way. Another way, I guess, is square. Let's see if another. I'm not sure the other way. You do always trial error. Maybe this. Yeah, no, it's not. Oh, okay. Yeah, let me see. Yeah, so you have to call it something else. Because once you already have called something square, then that thing will not be taken anymore. Let's say 1. So let's see if it's again a square like this. Yes. So either way, either you multiply GNP by itself, or if you write this caret 2 will give you a square. You want to see, let's see them. GNP and square of GNP per capita. Here, look, 810 at this big number, 460 and this big number, and so on. So the a square is generated. So generate is a GEN is a kind of useful command if you want to generate a new variable. Can you generate an inverse variable? Like if you want to say inverse of GNP per capita, how do you do that? Guess? Hello?
INV?
INV? No, I mean, whatever you want to call it, doesn't matter. The right-hand side here is what matters. Okay. Then obviously it will generate. Whatever you write here doesn't matter. What you wrote here actually is important.
So to the power -1 bracket.
Maybe. So let's say in GNPPC, I would go like this. Let's see if it works. 1 over GNPPC, okay? That's the inverse. Yes, generated. If you want to see, you can see GNP and INV GNPPC. Yes, here you see. If you want to see, you can see 810, 1 over 810, 460, 1 over 460. So this is the inverse of GNP per capita. Any questions so far? Remember, you need log or square or inverse for different types of models. Log model, you need to convert the variable into logarithmics. The last homework last one, did you have 1 by something? Huh?
I had a decimal, like I wrote it in decimal, Professor.
No, whatever it is. But in the last homework, did you have in the model? Did you have something like 1 over something?
In number 5.
Huh? What was the what was?
Yes, Professor.
Yeah, yeah. So if you need 1 over something, then that means inverse. You can generate inverse. Okay. So any variable you need, you can generate from the variables you already have. Just simple command gen. What else? Let's do some real stuff. Correlation. You want to know correlation? Have you? Do you remember the correlation between variables? Huh? Correlation coefficient.
Yes.
Correlation coefficient ranges from -1 to +1.
Yes.
And -1, close to -1 is very strong relationship. But if one variable goes up, another variable goes down, and so on. And if it's close to +1, this is very strong relationship, but positive relationship,
Both goes.
a linear relationship basically. So you can check the correlations. Let's do correlation between these three. Okay, LXP, GNPPC, population growth. You can do 2 also, 3, 4, doesn't matter. You just write COR, correlation. COR space variable, 2, at least 2 and more than 2. Here, correlation matrix is given. 63 observations because GNP has 63 observations. They have calculated correlation coefficient. How to explain this result here? So basically, you will get one correlation here, LXP, GNPPC. Two correlation. Correlation number 2, GNPPC, population growth. Another correlation, LEXP, population growth. Okay, so 3 coefficients of correlation you will get from this. One, LEXP and GNPPC. Here, this, look at this column, and first column is with LEXP, and here with respect to the variables. Take one LEXP, and first one 1, because it's between LEXP and LEXP. Correlation of a variable with itself will always be 1. Then hello, Afia Akhtar, can you turn off your video, please? Hello, Afia Akhtar, can you turn off your video, please? Okay, so between LEXP and GNP per capita, here 0.712. Once again, between LEXP and GNP per capita, 0.718. What does it mean? Huh? Hello?
It has a positive relationship.
Between?
LEXP and GNPC.
Exactly. And between LEXP and population growth, here, LEXP and population growth is minus 0.42. It's a negative linear relationship, but relationship is not very strong. It's a negative linear relationship. And another one, here, GNP per capita and pop growth. So you come here. This is for GNP per capita. And last one is population growth. So GNP per capita and population growth is minus 0.358. Negative relationship, not very strong. So basically three correlation coefficient you can find from here. One between LEXP and GNPPC, which is 0.718. Number two, LEXP and population growth minus 0.42. Number three, GNPPC and pop growth, which is minus 0.3580. So more or less, you have covered a lot of descriptive statistics. Many other things can be done, graph and all this.
Professor, so if it is a positive and negative relation, then it's weak correlation.
It's correlation, just correlation, nothing to do with regression. Okay,
No, I said that like weak correlation,
which one?
weak negative correlation. Like if one is positive and another is negative,
Yeah, it could be. It could be. Why not?
and if both are negative,
Huh? What do you mean?
if both, like for example, if GNPPC is negative and LEXP is also negative, then what
No.
correlation do we
You missed the whole point. It's between two variables.
Okay.
It's not only one. So what is this 0.718? Huh?
It is GNPPC and LEXP.
Yeah.
Right.
So what is that? That is the correlation coefficient
Correlation
between
coefficient.
LEXP and GNPPC.
Okay. Got it.
Intersection of this. Okay. And
Yeah.
what is this minus 0.42? This is the correlation coefficient between
Pop growth and LEXP.
LEXP. What is this minus 3.5 minus 0.358?
GNPPC and pop growth.
Yeah, correlation coefficient between these two. GNPPC
Sorry.
and pop growth. Yeah. So correlation coefficient can be positive, can be negative, and we know how to explain that. This is a linear relationship.
Professor, what about the 1.000 GNPPC and
The
GNP?
diagonal elements. So this is like by definition.
Not this one, the second line.
Yeah,
Yeah, this thing.
it's the same. Is between GNPPC and GNPPC itself. So it's mechanically doing it. Okay, correlation coefficient between a variable and itself is just one. It's a perfect relationship. X with X itself. Okay, so not interesting for us. It's by mechanically they are calculating these diagonal elements. So what is this one? Last one.
The population growth and population growth
Itself with itself. Any variable with itself, population that correlation coefficient will be obviously 1. It's a perfect 100% relationship. Okay, not interesting for us. For us, we want to know the relationship between these variables here. So that is the correlation coefficient. Then what else? The next thing, obviously, we are waiting for the so-called regression analysis. So let's do one regression, okay? The regression we did so far. So what is your dependent variable? First, so regression, you can write REG, reg. Or you can write regress, REG, RESS. So let's write REG, reg. What is your dependent? First, you write your dependent variable. What do you think? LEXP, life expectancy depends on what?
On GNPPC.
GNP per capita? Okay,
Yeah.
let's do it. So you can do it. REG, and first you write Y variable, dependent variable, then you write independent variable. More than one, let's do it one independent variable, which is GNP per capita. So what is the model here? Model is dependent variable life expectancy equals beta 1 plus beta 2 GNP per capita plus U. That model is, now we are going to estimate the model. We are going to estimate the model. Just one line, REG, dependent variable and independent variable, and you hit enter here. A lot of results are in. We cannot explain all of them because we did not learn so far. We learn everything from here. Not everything, almost everything from here. So once again, you are going to find the regression estimation of model. Let me write the model. Model was like this: LEXP equals beta 1 plus beta 2 GNPPC plus U. This was the model. Can you see this command here? It is not a command. I'm just showing you the econometric model was this, and you wanted to estimate this model. And what did you do? You wrote REG, LEXP, GNP. So the software is using OLS principle to find beta 1 hat and beta 2 hat. Okay. So what is beta 1 hat here? In this, here, constant, they write. So here, this is how you read. Look carefully. LEXP, here in the corner, there are a bunch of things. Go down here. LEXP. So what is here? The dependent variable is reported here, LEXP. Then you have first thing, independent variable, GNP per capita. Then you have a constant. Constant means basically beta 1. So GNP per capita and beta 1 here. So the coefficients of GNP per capita is here. You see, COEF. So that is the coefficient of GNP per capita. That means beta 2 hat is this, and beta 1 hat is 69.44. So from this result, at least we know two things. One, beta 1 hat, I don't know how to put hat here. So beta 1 hat equals what? Tell me. Huh?
The constant 69 points.
69.4483.
4483.
And beta 2 hat? Whatever it is. It was 0.0003. So this is the, I use those formulas in the software and gave you these results. And what else? So can anybody explain the beta 1 hat here for me? How do you explain this number 69.448?
If GNPPC is 0,
Yes.
Life expectancy is 69.448.
Anybody else? Hello, anybody else? Nobody wants to say a word? I've shown you such a magic. All the results are in here, just one click. Anybody else wants to explain beta 1 hat? Afra, are you there? Hello, Afra. Are you taking a nap? Ashley Biju? Hello, Ashley. Are you there?
Professor Afra replied in the group chat,
Huh?
the chat box. Afra replied in the chat box.
Yeah, so in the chat box, she's not answering. Can you answer, Afra? Can you unmute yourself and answer? Okay, no. Chani Dema? Chani Dema? Hello? No. Okay. Fahima Baig? Faiza Bint Harun? Hello, Faiza. Farishta,
Yes, Professor.
how do you explain this beta 1 hat? 69.448.
Can we say that it's linear in parameters?
No. You have a number here. You want to explain this number. What linear in parameter?
I think the one my peer explained it was okay.
Okay, what he said is okay. Anybody else have any other ideas? A little bit different? No.
Professor,
Yes.
when GNP is equal to 0, then the life expectancy will be 69.448.
Say it again. Say it again. When?
When GNP equal to 0, the life expectancy equal to 69.484.
No, you have said exactly what she said. Exactly same.
Professor, can I try?
Yes. Who's this?
Alpana Akhtar.
Okay.
So if GNPC is 0, GNPPC is 0,
Mhm.
on average life expectancy
Fancy.
is 69.448.
Exactly. You can never forget that regression is giving you on average result.
Professor, like,
Yes.
should we say like on average it will increase by?
No. Increase is
No.
related to slope.
Okay.
This is an intercept. What is beta 1 here?
Beta 1 is intercept.
Intercept. So then if I ask you to explain beta 2 hat, how do you explain? This 0.003? Anybody?
What,
Huh?
Professor?
Yes. Go ahead.
Professor, what you said? I didn't get.
How do you explain beta 2 hat, which is 0.003?
Professor, can I
So
try?
if
Yeah, try. Go ahead.
Professor, if GNPPC increase by 1 unit,
Mhm.
then life expectancy on average increase by 69.44
No,
unit.
wrong.
No,
What is
0.003.
No, 0.003 unit.
Yes. So that is the slope. One is intercept, which is 69. Another one is slope, 0.003. So if GNP per capita increases by $1, life expectancy at birth on average increases by 0.003
0.003 unit.
years. You see there,
Yes.
then you have to look at the units of measurement. Remember here, the units of measurement will be given. Then you have to, you cannot say now generic unit. What is it, that unit? Is it year? Is it dollars and all this? So, so when you do a regression like this, the results are out there right away. For us, as econometricians, our duty is to explain these numbers. Okay, so will you make any mistakes when we were interpreting this intercept and slope coefficients? Will you forget the word on average? Huh?
No,
No.
Professor.
You like that. you will, and I will not be lenient next time. So then one more thing we have learned, which is R squared. Remember R squared? Huh? Do you
Yes.
remember R squared?
Yes.
That so-called coefficient of determination, goodness of fit, R squared. Yeah, what is the R square? R square is given here. R squared equals 0.51. How do you explain R squared? Huh? Anybody recalls R squared?
Yes, Professor.
Yeah, go ahead.
0.51 y can be explained by x.
Yeah, almost there.
It was
Yeah. Anybody?
like
Yeah, you were almost there. Yeah. Anybody else wants to slightly improve upon her definition?
0.51 life expectancy can be explained by GNP per capita.
Not 0.5. Yeah, 51%. 51% of the variation of life expectancy can be explained by GNP per capita. True. 51% of the variation of life expectancy can be explained by the X variable, which is GNP per capita, or by the regression. So are you guys okay so far? Huh?
Yes, Professor.
Sir, I did not understand R squared.
If you don't understand, then you miss the theoretical class.
No, Professor, I was present in all.
You were present. Did you explain R square in that class?
Yes, Professor.
Anyways, let me explain again. So R square is called goodness of fit or coefficient determination, and we derived actually from explain sum of square, total sum of square, residual sum of square, if you remember. So, and then it's an R square is nothing but, for formula, R square is ESS divided by TSS, if you recall. ESS is explain sum of square divided by total sum of square. So it's a ratio. Explain variation of y divided by total variation of y, and that is called that is called coefficient of determination, also denoted by R squared, and that is here 0.51. How do you explain? You explain like this: 51% of the variation of y is explained by x. What is y here? Life expectancy. What is x here? GNP per capita. Okay. Yeah, you have to be always updated in the theoretical class, because this class is not about going back to the theoretical concepts and all. This class is about using those concepts, using data, finding the numbers, and interpreting the numbers.
Yeah, Professor. Now I remember, because in my notebook it was written SSE instead of.
Yeah, SST or TSS is
I
same.
got confused.
Yeah, SST or TSS is same. SST or TSS, SSE or ESS is the same. So that's how you explain R squared. And did you all do my inter-micro class?
Yes.
Yeah.
So if let's say life expectancy not only depends on GNP per capita, also depends on population growth. So in that case, we can write, we can extend the model, okay? Can we? Even though we did not do in the theoretical class. So we can extend the model.
Yes, Professor.
And we can say we can bring another variable, which is what? Population growth. So so it's easy. It's here in the. So let's say we believe that life expectancy not only depends on GNP per capita, plus also on population growth. So we brought this new variable here. Now you have two independent variables and one dependent variable. Okay? Everybody with me here?
Yes, Professor.
So now you know that if a variable, a dependent variable depends on more than one, then this, let's say beta 2 or beta 3. How do you get beta 2 and beta 3 in a, forget about you, okay? You don't worry about you. Just to see the concept. How do you get beta 2 in a derivative term?
We have to hold beta 3 constant, then we can find beta 2.
3 is, yeah, we have to keep population growth constant, keeping other variables constant. So you keep population growth constant. Then if you say GNP per capita increased by 1 unit, life expectancy increased by beta 2 units, and so on. Okay. How do you get beta 3? Explain beta 3. Hello? You keep GNP per capita constant. Then you say, if population growth increased by 1 unit, by how much? Life expectancy obviously on average increases. That is beta 3. Everybody with me here?
Yes, Professor.
Huh?
Yes, Professor.
So that is partial derivative, remember?
Yeah.
Instead of usual derivative, you have to do partial derivative of LEXP with respect to GNP per capita and also with respect to population growth. So when you explain, that is the only difference for now for us when you have more than one X variable. So how do you do that regression is again very simple for us here in the software, not in the theoretical part. So that's why I would like to avoid that in the theoretical part. I mean, because that unnecessarily complicates our analysis. So what I do is here again, REG, Y, LEXP, GNP per capita, and what else? Population growth. Now software already knows that your dependent variable remains the same, LEXP. Your independent variables are now two, GNP per capita and population growth. So everything else is saying you just put, but don't forget the model, which I erased, but you know the model. Here. I hit command as enter, and you get this, all the things here. Look, constant now is what? Hello? Do you see now the new result here? Hello, guys.
Yes, Professor.
Yes, Professor.
So what is the beta 1 hat here?
70.6.
Let's say 70. Okay, 70. How do you explain that? Interpret beta 1. For us, just okay. No theoretical questions. It's just interpretation of these numbers.
So if the coefficient, right, Professor?
What coefficient?
Sorry.
Life expectancy.
Be sure when you, yeah, go ahead. Beta 1 hat 70. How do you explain that?
Professor, if life expectancy is 0.
No, wrong. Life expectancy is the dependent variable.
Okay.
What is here is dependent variable. Here is dependent variable. Once again, in this corner is the dependent variable. This one is the
Independent.
first independent. This is the second independent, and the last one is the what? Constant. Beta 1 head.
Yeah, Professor, for this reason, I'm confused. Which one will be?
No,
So is that
you
like
don't be confused.
if
because
GN
you successfully explained this here.
Yeah.
Yeah. How can you be confused? Here it's what's
Over.
69.48.
Yeah, yeah. The value is
Did you
fine.
interpret this?
Yeah.
Yes. So how come you are confused?
So Professor, is that if GNPPC is 0, then on average life expectancy is 70.
Okay. Any other thoughts? Anybody else?
Or if population growth is 0, then on average life expectancy would be 70.
Anybody else? Are you guys here in this class? Other people? Naushin, are you in the class?
Yes, Professor.
So Naushin, what is your explanation?
Holding population growth constant.
Constant.
Mm,
Is it, what was the model? Let me write the model again. Oops. Model was LEXP equals beta 1 plus beta 2 GNP PC plus beta 3 what? Pop growth plus U. Now I'm asking you to explain beta 1 hat. How do you explain that?
So Professor, if we keep constant beta 3,
If you keep constant beta 3 is a constant. Obviously,
yeah, then
beta 3 is a constant. You don't have to keep it constant. It's a
okay,
parameter.
then if GNPPC is
Hang
0,
on, guys. How did you explain this 69?
if GNPPC is 0,
Uh-huh.
life expectancy on average is 69.44.
Yeah, now you come here. What is the difference here? The only difference is there is one new variable, okay? Now you want
Yes,
to
Professor.
explain this beta 1 hat.
Professor, is the same.
Say it again. Don't say same. Tell me the full sentence.
Uh, if GNPPC is 0, life expectancy on average is 70.
How come when you are talking about this, how can you ignore this variable? Because it comes later, that's why?
So what we never did
Professor,
with this.
hold it constant.
Full sentence. I want a full sentence.
Holding population growth constant.
Holding constant. What do you mean by holding constant?
Oh,
Why are you holding constant? Is a coefficient, is a slope? Is it slope? Beta 1 is slope?
So will population
Professor.
growth will also be 0?
Thinking. Let's forget about you, okay?
Yeah.
Forget about you.
Professor,
Yeah.
so will population growth also be 0?
Exactly. When GNP per capita is 0, population growth is also 0, then on average, life expectancy is
70.
70. Because forget about you. How can you get beta 1 if both of them are not 0? Is it possible to get beta 1?
No.
So GNP per capita and population growth both have to be 0. Then life expectancy on average would be beta 1, which is in our beta 1 hat, is 70. Is it okay now?
Yes.
yes,
You guys have to
Professor.
bit. Okay. Now, how do you explain beta 2? Which is, no, look at this number here. Beta 2 hat is what? Huh? The numbers are here. Now you have to explain the numbers. When you write your thesis paper, when you write your term paper, you have to explain the numbers.
Yeah.
So beta 2 hat is what?
Beta 2 hat is
0.00.
0.000293.
So 229. So it's a 3. Explain it.
Holding population growth constant
Yes.
if GNP per capita increase by 1,
Yeah,
life
$1.
expectancy on average will increase by beta 2, like 0.003.
Exactly. On average. True. How you explain beta 3 hat now? It is
Holding beta
minus
2
0.98. Yeah, go ahead.
holding beta 2 constant
Not
if
beta 2 is
population
already a
growth
constant. How can you say holding beta 2 constant? Beta 2 is a parameter. It's already
GNP
constant.
per capita
Okay. Holding?
hold GNP per capita constant
Yeah. Yes, go ahead.
if population growth increase by 1, life
Well, actually, here this
expectancy
is
on
percent.
average will increase by
Ah,
decrease by minus 0. Decrease by 0.98.
it decreased by 0.98 years. If population growth, keeping GNP per capita constant, if population growth increases by 1%, life expectancy on average decreases by 0.98 years, almost 1 year. Life expectancy decreases almost by 1 year when you keep GNP per capita constant and population growth increases. Does that make sense? Hmm? Population,
Yes,
Professor,
yeah. Yeah, go
can
ahead.
we get a break for prayer?
Yeah, we are done for today. I'm not gonna do more than this for today. Uh, I have shared the uh, this data set. Have you seen the data set 6.4, table 6.4?
yes.
Okay,
yes, Professor.
Yes,
just yeah, one
sir.
more thing. Okay, so now we did all these things from the system. We will just show how to import the data, and then you do the same thing instead of
But
system.
Professor, I think we need to know the command.
Yeah, yeah, I'll send the commands to you. Okay, but before that, how do you import data set from the Excel? So I have a data set, and I shared that with you. Table 6.4. I'll just show how to import that data. It's very simple. You copy from the, so I'll erase everything else. How do you erase everything else? You just say clear.
Control L.
Clear.
Here.
Just say clear. If you want to save this, you have to save it separately. Okay. You save it separately. I'm not gonna save.
Professor,
Here,
how to save? Just normal saving?
yeah, you have to save it there separately. You copy it, save it somewhere. Then you say clear. If you say clear, everything will be cleared. Everything's gone. Now, just last thing for today. Here, I have this table. I don't want to, you have already that table. Maybe I can show. So you see this table. Here, this table. Okay. Can you see the table now?
Yeah.
So it's a CM, FLR, PGNP, TFR. What is CM? CM is child mortality. FLR, what is FLR? Female
Female
Literacy
literacy rate.
rate.
PGNP, what is that?
Total fertility rate.
No, per capita GNP. You are
The
looking at here. I skipped
TFR.
that one. PGNP, per capita GNP. TFR, total
Total fertility.
fertility rate. So we have this data in a separate Excel file, or you will have your own data when you do your research. You copy it. Okay, this is my uh, silly way. Copy it here, copy. Okay, then I go back to my uh, Stata. I go back to Stata. Here, this Stata file. What do you do here? Okay, let me show you. Here is this. It's not showing, coming up. Let's see if it's comes up. Yeah, you see data editor, edit. You see this icon with a pencil there?
Yes.
Yeah.
Hit there. If you hit on that icon, you will see this Excel like sheet, and you say paste. Here you are saying paste. Okay, you just paste it. When you paste it, it will ask, is the first row data or variable names? You see that in our table, the first row was the variable names, CM, FLR, and all this. So I said, treat first row as variable names, and everything is here. The whole file, CM, FLR, PGNP, TFR, everything is in now in our data. You see, CM, FLR, PGNP, TFR, everything is here. Now you can do whatever you want to do. So you can close it. It's already saved. You don't have to save it
So
separate.
that means we have to create a table first in the Excel and then copy
If you want to do your research, you collect data. Yeah, then you create that Excel sheet.
Professor,
Yes.
is there any way to save insights data, or do we need to just save it like clicking the save
You can
button?
save it. You can save it separately. You save it separately. It will go in the system. But I always suggest, if you have Excel file, keep it in the Excel file. Okay, a clean data set in Excel file. Whenever you need, you bring it from there.
Okay.
Use it. So here is all the variables. If you want to see all the variables here, you just write list. List CM, FLR, PGNP, TFR. If you write list, you will see that here they are here now. You see, CM, FLR, PGNP, TFR. Now you want to do whatever you want to do. You want to write regress? I will say regress. Child mortality depends on what? Huh? Female literacy rate,
Yeah.
per capita GNP,
Mm,
or if you need all three, TFR, total fertility rate. Child mortality depends on, now you have three variables in the set of independent variables. 3 X variables. You can do 3. You say hit. All these are here. Constant values, TFR, coefficient of TFR, coefficient of PGNP, FLR. First one, here, you start from here. First X variable, second X variable, third X variable, and the, so beta 1 hat. What is beta 1 hat here? Huh?
beta 1 had 168 point
Yeah, okay. How do you interpret that?
interpretation.
Yes.
Over here, do we have 3 more? So holding FLR and PGNP constant.
No.
no, if those are 0.
Yeah, if FLR equals 0, PGNP equals 0, TFR equals 0, then
Then on average CM,
which is child mortality.
yeah,
child
is
mortality is
168.
equal to
160, actually in 1,000 maybe, or in 10,000. I'm not. We have to look at the coefficient. Then how? Just explain this FLR, and we'll call the day today. How do you explain this?
Holding other things constant.
Huh? Keeping what?
Other things constant, like
What other things here?
PGNP, then TFR.
increase.
Okay.
Increase.
If
If increase by 1,
what increased by 1?
The
PG.
FLR, right?
Huh?
No, we are explaining FLR. Or
Yeah.
if we increase FLR by 1, then on average, child mortality rate will increase by
Decrease.
Will decrease.
by 1.768.
1.76768. Yeah. So be careful when you are doing your units. Have to be very clear, and you explain by your own units and all this. So do everything whatever we did, you do with this data set. I'll share the comments, and you practice. Without practice, you can never learn a software. So you have this data set, you do everything with this data set. Or also you can do the one that is in the system using sysuse. Okay?
Yeah.
All right. then.
Professor, we know R square, but what is ADZ R squared?
No, you don't worry about those things later. You will worry about those things later. Right now, whatever we learn, you try to interpret them clearly. Everything we
That is
learn.
adjusted
Later
R
on, we will
square.
learn everything. Yeah, R square is here. Oh, you want to explain R square here?
Not R square.
No R
A
square?
Sir, she is
ADZ.
asking about adjusted R square.
What do you mean by no R square here? Here is R square.
No, Professor, I didn't say about this.
So, yeah. So what is your question? Huh?
Professor, she is telling about adjusted R square.
No. Don't worry about those
That is
things later.
written.
We'll worry about those things later on. Yeah. Right now, you just explain these coefficients and this intercept and R square very clearly. And there are many other things we'll be explaining later on. This is a ANOVA. Have you heard of ANOVA from your probability statistics class?
Oh, Professor.
Yes,
Yeah,
Professor.
this is an ANOVA. This is a t-test here. This is adjusted R square. And there is another test, F test. We'll explain everything and confidence intervals here. Everything will be explained later on. Okay, so I would say that's it from me for today. I'm gonna share this command file with you guys, and you practice them. Okay, if you don't practice, nobody can teach a software. I tell you, nobody can teach a software without practice. I'll just show you the basic stuff, and then you are on your own. And you have everything on the YouTube, so no worries. All right.
Yes, Professor.
Yes.
So let's end the class today. Okay.
Okay. Thank you, Professor.
Okay. Thanks. Bye.